Let's continue with our 7-part series on what raises and lowers specific chemistries in a swimming pool. This is number 2 out of 7. In the last episode, we discussed what raises and lowers pH. And in this episode, 92, we are going to be discussing what raises and lowers total alkalinity. Now, before getting into this, we cover alkalinity in a lot more detail in episodes 1, 2, 29, 35, 46, and 62. So let's get into it.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go.
Since most of you are not going to pause this episode and go back to listen to those previous ones, let's do a brief overview of what alkalinity actually is. Alkalinity is how much dissolved alkali is in your water. Basically, what is in your water that can neutralize acids. And we measure this in parts per million, or for the metric system, milligrams per liter. You want enough of this because this is considered the buffering capacity. And when we're talking about acidity and alkalinity in water, you're really talking about the ability to take or give a hydrogen ion. The vast majority of what you're going to have in your water is going to be bicarbonate ions. You will also have carbonates, and those two together are called the carbonate alkalinity. They function in equilibrium based on pH. There's also cyanurate alkalinity. There's also borate alkalinity if you use it. Now, these are smaller, but they do need to be factored out when you're calculating the LSI, because the LSI formula requires the carbonate or corrected alkalinity. And believe it or not, to a very, very small, I would argue negligible amount, phosphates actually also contribute to your buffering capacity, but it's so small it's not even worth measuring. To make this easier to use in the real world, we decided in our latest app update in the Orenda calculator to add a secondary reading for just your carbonate alkalinity. We do all the math for you, so we automatically deduct your cyanurate and borate alkalinities from your total alkalinity so you can see it. You don't really need to do anything with it, but it's important to know because that's the number that goes into the LSI, and it's also the number that determines how high your pH can naturally rise, which is something we call the pH ceiling. We discussed that in the last episode. Now, the purpose of alkalinity, as we go in depth in episodes 1 and 2 of this podcast, it's pretty important. We literally started the Rule Your Pool podcast with the first 2 episodes talking about this. It buffers pH from moving too rapidly. Particularly, it buffers against a rapid reduction in pH. Acid has to neutralize alkalinity in order to lower the pH. This occurs because acid converts bicarbonate into carbonic acid, H2CO3. Carbonic acid is actually dissolved carbon dioxide. And your pH is largely determined by how much dissolved carbon dioxide you have in your water. The more dissolved CO2, or the more carbonic acid, the lower your pH. So it's important because acid is actually, as I say, burning through alkalinity to convert it to CO2 to bring your pH down. You can go on our blog, blog.orendatech.com. In the search bar there, type in alkalinity. All of those blogs, and there's many of them, they all have this chart, and you can look at this chart and you will see that the x-axis is the pH. And as you move left or right on there, you will see that these species of alkalinity change based on the hydrogen concentration. So it'll make more sense if you see it, but don't worry about the science. Just know that the more alkalinity you have in your water, the more acid it takes to do a given pH reduction. So like if you had 120 alkalinity and you wanted to go from 8.0 down to 7.5, your dose would be, let's say, a quarter gallon of acid. But if you cut your alkalinity in half and now you have 60 alkalinity, it's no longer a quarter gallon. It's a half of that. It would be a pint. It would be 16 ounces. So the amount of alkalinity determines the amount of acid it takes to do the same pH correction. Let's talk about what raises alkalinity. What causes alkalinity to increase? Now, the easy way to raise alkalinity is to put in sodium bicarbonate. You are Literally adding more bicarbonates to your water, alkalinity goes up. pH will go up a little bit too, but basically it's baking soda. You're just introducing it to the water. Similar with soda ash, although soda ash is like 1,000 times more concentrated, so you would not be able to use nearly as much because you would cloud up your pool. Soda ash introduces carbonate ions. That counts too. You're just adding a lot less of it, so it's not very effective at raising your alkalinity in a big way. If you're trying to raise alkalinity in a big way, you're going to use sodium bicarbonate. That's really the only way to do it. But there are other ways to increase your alkalinity in a more slow way, I should say. The other way you can introduce alkalinity is through hydroxides. Now, hydroxides are not on that chart that I was just referring to, but a hydroxide is the opposite of a hydrogen ion. So in pH, we're talking about H2O getting split. The hydrogen breaks off, that's the acid, and the hydroxide is the OH minus. That's what we're talking about. So when you have something like sodium hydroxide in liquid chlorine or calcium hydroxide in your plaster, that ends in an OH. That will neutralize acid and it'll create water. So if you have hydroxides being pulled in, the unfavorable one, of course, is calcium hydroxide because it means you either abused acid by overdosing it or not diluting it or something, and you dissolved some of the plaster material. The most soluble form of calcium in your cement is going to be calcium hydroxide, so it pulls it into the water. You get new hydroxides in your water. They neutralize some acids, and your alkalinity starts to creep up. Not in a big way, but technically it will start to creep up. A more common way with hydroxides is going to be from your chlorine. Now, you don't notice this because it's a very small amount, like liquid chlorine and cal hypo. They're actually pretty pH neutral after they do their oxidation or killing. HOCl will kill something, and then that oxygen, the O, gets swapped for an electron and it becomes HCl, which is hydrochloric acid, muriatic. So it kind of neutralizes itself, but you have this little excess hydroxide. It's a small percentage, but it's there, and that can eventually accumulate. But you would never notice this if you use acid regularly, like once a week or on a feeder to correct your pH. That acid would easily negate that. Where you notice it is when you're not using acid for pH reduction and you're using carbon dioxide. If your swimming pool injects CO2, you will notice that your alkalinity not only doesn't go down, it tends to go up over time. It goes up because of the excess hydroxide in your liquid chlorine or your cal hypo. Both of them have it. You're just not noticing it when you use acid. So that's the other way it goes up. Another way is your tap water. Your tap water could have high alkalinity. And so if you have splash out or evaporation and you're introducing more high alkalinity tap water, boom, there you go. More alkali is in your water, your TA goes up. And finally, if we're just raising total alkalinity but not carbonate alkalinity, as I mentioned before, technically adding cyanuric acid or borate will increase the total alkalinity. Not in a really noticeable way though. So I want you to be clear that it's not going to jump out to you and say, yes, I've raised my cyanuric acid by 10 parts per million. Yeah, you're not going to notice it then. It's roughly a third of your CYA that would actually contribute to your total alkalinity. So it goes up pretty slowly. Anyway, to recap, if you're raising your alkalinity, you are increasing the amount of alkali in your water, whether it came from your tap water or it was this small amount of excess hydroxides, either from your surface or from your chlorines. More noticeable if you're using CO2 injectors. But the main way is sodium bicarbonate. Now let's move on to what causes alkalinity to go down. What causes it to decrease? Well, if you want to lower your alkalinity, you need to get alkali out of your water. In most cases, you need acidity. You need an acid to neutralize that alkali. So, acid, whether it's muriatic acid, which is hydrochloric acid at 31.45%, sulfuric acid, or sodium bisulfate, all of them are going to convert alkalinity by adding hydrogen to them. If you have bicarbonate ions, it's going to convert bicarbonate into carbonic acid, which is dissolved CO2. It brings the pH down. And then that CO2 reconverts in off gases. That will bring the pH back up. Those are the main types of acid that will neutralize alkalinity. But there's also acidic chlorines. Technically, chlorine gas is very acidic. That would neutralize it, although chlorine gas is pretty much banned everywhere. And the chlorine gas that's created in a salt chlorine generator gets neutralized by sodium hydroxide. But we're getting into the weeds. How about trichlor? Trichlor 3-inch tabs, you know those chlorine tabs that someone might put in your skimmer, but they never should? Those have a 2.8 pH. They will absolutely be reducing your alkalinity because that low pH is neutralizing alkali in your water to create more CO2 to lower the pH of the pool. It's part of pH suppression. There are also acidic pool additives like sequestering agents, but to be honest with you, they do not make much of a noticeable impact on total alkalinity, but technically they do exist, so if they're acidic enough, they could lower it, but really not a thing. We're really talking about acid. Now, another way that you can reduce alkalinity is with dilution. If you splash out swimming pool water and you replace it with tap water that has a much lower alkalinity, your alkalinity will go down. Vice versa, if you splash out swimming pool water and you replace it with very high alkalinity water, your alkalinity will go up. It's no different with any other chemistry. So we're talking like losing water through your overflow during a heavy rainstorm. That'll absolutely lower your alkalinity. Same with snow. Or extended backwash cycles and replacing your pool water with lower TA tap water or pool leak, things like that. You can also do a deliberate draining and refilling, but that would not be for alkalinity. You could neutralize alkalinity with acid. It's much cheaper. The reason you would do a drain and dilution is for something like cyanuric acid or total dissolved solids or really high calcium that's not allowing you to maintain your LSI. So, as a recap of all of this, if you want to raise your alkalinity, you need to introduce more alkali to the water. The easiest way to do that is with sodium bicarbonate. If you want to reduce your alkalinity, you need to remove alkali from the water or neutralize it. The easiest way you do that is with acid. Yes, there are other ancillary ways, but they're smaller and they don't make nearly as much of an impact as sodium bicarb and muriatic acid. I'm Eric Knight with Orenda. This has been episode 92. I hope you find it valuable. In the next episode, we're going to be discussing how to raise and lower calcium hardness. We'll see you there. Thank you.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.